Hello, ELT132. So this is a video on basically taking a truth table to a Boolean expression. So before, what we did is you had a schematic, and then you got to you turned it into a Boolean expression. Then you were given a Boolean expression, and you turned it into a schematic. Now what's happening is we are giving you, or you are being given, a truth table, and we want to turn that into a Boolean expression. Think about it. If you can take a truth table and turn it into a Boolean expression, then you can take that Boolean expression and turn it into a schematic. You could build the circuit, and bingo. I mean, you can do just about anything, right? So, all right, so let's take a look at this. So my question for you is, if you take a look at this truth table here on the left, when is y equal to 1? So y is equal to 1. Let me just write that. Oh, you know what? I got to do this here, don't I? There we go. When is, right, y equal to 1? Big old question mark there, right? So it's going to be equal to 1. A equals 0. And B equals 0. And C equals 0, right? You agree with that? I mean, here we have when A is 0, B is 0, and C is 0, y is equal to 1, right? When else is it equal to 1? Well, let's come down here. It looks like when A is equal to 0, right? B is equal to 1, and C is equal to 1. How about the next one? What about this one? It's also equal to 1 when what? When A is equal to 1, right? And B and C are equal to 0. I just draw slashes through my zeros generally. That's just how I do that. So there are 3 unique cases here when y is equal to 1. Right? So let's speak these things, and let's write it as we speak about it. So then y equals 1 when A, I'm going to make 0, I'm going to call it A bar, with A bar B bar and C bar, right? So when these are all 0, A is 0, and B is 0, and C is 0, right? That's a gate, right? It's an AND gate, basically. That could be 1. Or, well, it's an or, we're going to have a plus sign there, right? It's going to be when A is equal to 0. I'm going to say A bar, which means it's low. We have B equals 1, or C equals 1, right? Get it? So it's or A low, B high, C high, right? There's different ways to say it, but I'm sure you get the idea. Or when A is equal to 1, or A is high, and you have B bar, C bar. Y. Let's make that Y. So there's your expression for when y equals 1. Look at that. It's 3 input AND gates, and they're all ORed together in an OR gate, right? So let's take this expression, right? If you just look at this expression, find out what rows, right, where y is equal to 1, And then you simply just write them out, just like this. Or you could write this out and then transfer it, however you like to do it. But this is the form you want to end up with, okay? You want to end up with this form right here. No, whoop. Sorry about that. My drawing skills need a little bit to be desired here. Now I want to show you something. This right here is a product, all right? A dot B dot C. This term right here, that's a product, isn't it? And this term right here, that's a product, isn't it? And you're taking the sum of each of these products, because there is your plus sign. So this form, what you see right here, is denoted as SOP. And this stands for sum of, I should put that small s, right? Products. Get it? Sum, it's the sum of each of the product terms. Now, why don't we just, while we're at this point, let's just draw the circuit. Why not? Right? What do we have? A, B, C? A, B, C. Whenever I see an expression, I just automatically want to draw it, I'm sure you feel that way too. That's why we're doing it together, right? Alright, A, B, C. What do we have here? A bar, right? This is over here. B bar. C bar. Now, let's draw the first one. What's the first term here? What is that? That's a 3-input AND gate, isn't it? Well, here's your AND gate. Okay. We'll take one of A bar, which is right here. We'll just take it on over here. We'll take B bar over there. And then we'll take C bar over there, right? There's one of them. What about this one? We have a second term, don't we? Here is your AND gate. And we have A bar, B, and C right here. Just make sure that's on there. So that's your second term. What about your third term? It's another AND gate. Has to be. It's sum of products. This is going to be A, B bar, and C bar. All right? That's each one of your terms. Now, what do we say has to happen? They all have to get ORed together, don't they? So simply, you could take this down. 1, 2, 3. You could just simply run this into a 3-input OR gate. This is your OR. And these all come in there. And then Y will equal that expression. All right? Now there are two flavors. There's one called sum of products, and there's one called products of sums. So this was the sum of products portion, okay? So now, let me do the product of sums. Well, let's do that in the next video, right? So this is the SOP method. I hope this has been helpful to you, and I will see you shortly. Thank you.